algebra class. There's a famous story about a wise man who helped a king out. And after he helped the king said, you know, sir, after you've done this, I'm willing to give you anything you want, up to half my kingdom. And the guy goes, oh, king, I don't want very much. All I want is there happened to be a chessboard there. He said, I just want a grain of rice for the first square, 2 grains of rice for the second square, 4 grains for the third square, and so on up to the last square. That's all I care about, king. And the king goes, oh, that's all you want? Okay, take it. Well, when he actually figured this out, and we'll do it in a second, is you figure out that this amount of rice is worth more than all the rice in the world, and it's worth more than the king's kingdom himself. So that's the power of exponential growth. That's what we're going to talk about today, exponential growth. Okay? So it's growing not just like, like families grow where it's, 2 people have 2 kids and then they have 2, and it, it kind of just grows one upon the other. It's multiplying by a factor of 2 or 3 or 4 or 5 sometimes, and it grows very fast. The formula that we're going to look at, the problems aren't really hard, but the formula you have to understand, okay? So the formula kind of goes like this. Y equals, so this is our end product, and it's going to be whatever you start with, and I'm not going to put like the original O for original, because then it's going to look like a 0. So I'm just going to put an S for the starting amount, okay? And then we're going to multiply that by 1 plus, and there will be a certain percent here. I'm going to put X. And then this is going to be to an exponent that's going to be the time. Now, at first, when you look at this, it looks really kind of freaky, okay? But it's not that bad. Starting amount should be easy to figure out. Let's just pretend that this part wasn't here. If you multiply your starting amount by 1, what are you going to get back? Yep. Your starting amount. If this was a certain percentage, like let's just pretend that it's 5%. Now what's going to happen is you multiply the starting amount by 1 and you're going to get the starting amount back, but we're also going to get a little extra, right? There's going to be 5% more on top of that. If I just had you multiply the starting amount by 5%, though, do you see you're not going to get even your original amount back? That's going to be a ripoff. Like, I give you $100, and then I say, okay, pay it back to me with interest, and you just pay back to me the 5%. Well, I'm not going to like that deal, okay? Because then you got all my money and you're only paying me back 5% interest. I'm going to want the original amount back plus the interest. Okay, does that make sense? And then the key thing about these, the reason why they're called exponential growth problems is because there's going to be some exponent here that relates to the time. So if you guys have your calculators out, let's practice a couple problems. Let's do a simple one, and I'll just use numbers that'll be easy to do. Let's say that I loan Elliot $10. So for this problem, it's going to be, I don't know what my ending amount is going to be. That'll be Y. But Elliot starts with $10. And I say, Elliot, at the end of every week, you're going to pay me back 10% on that $10 until you pay it back to me. And you don't pay me for like a year, let's say. So remember, we're going to multiply by 1 plus the amount of percent interest that he's going to pay me, which is going to be 10%. And I'm just going to turn that into a decimal, so it's going to be 0.1. Is that okay? And then it's at the end of every week, remember, and it's going to be for a year. So what's my exponent going to be? Yep, Jensen? No, it's the end of every week. 52. Isn't there 252 weeks in a year?
That was close.
So why don't we try this out? Try 1 plus 0.1. So 1.1 exponent, so to the 52nd power, and then times that by 10.
Not quite the high number.
Look at them working. Ooh.
Oh, hello.
YOLO!
They're working hard. And when they get the answer, what is it, Kimberly?
1,420.43.
1,420.
I got overflow.
I didn't.
So, at the end of a year, if Elliot does not pay me back, and we're doing this interest rate every week, he's going to owe me $1,420 when he just borrowed $10. Okay? Bad deal for Elliot, good deal for me. So do you understand kind of the power of this? It really multiplies quickly. Okay, let's do the one with the grain of rice. So the grain of rice, we're going to figure out what it ends up with, but he starts with 1 grain of rice for the first square, correct? For every square after that, it's going to double. So it's going to be 1 plus, what percent now is it going to be, Natalie? 200. Well, it's not going to be 1 plus 200, Adam.
1 plus 100.
Right. It's going to double, so it's going to be this gets itself back, and we want 100% more than that, right? So it's doubling. So it's going to be 1 plus, and if I turn 100% into a number, it's just going to be 1 plus 1. Does that make sense to everybody? And then, how many squares on a chessboard?
64.
64.
Yes.
So this is going to be to the 64th power. So why don't you figure this out? How much rice is going to be at the end? So they're figuring it out. They're crunching the numbers. I hope you guys are at home too.
What do you do?
When we come back, what do we have? Bennett?
1.84467.
Just round it. 1.84
Alright,
times 10 to the what?
11.
10 to the 11th.
I got 19 or 19.
10 to the 19th?
What?
10 to the 20th.
Good job.
Mine says 11.
Okay. So what this number is going to be, if I wrote it out, let's just go to the 19th. Okay? Let me erase some of this.
Oh, yeah, I got 10 to the 18th.
Shh. All the chattering, remember. Okay, so let me erase some of this. 1.84, and we're going to go 19 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 0, 0, 0. Ooh, I'm not even going to be able to say this number. I was going to try to do billions, trillions. So, millions, billions, trillions, quadrillions, quintillions, sextillions. So it's going to be 18 sextillion, 400 quintillion grains of rice. And again, if you figure that out, that's more rice than there is in the world. Okay? So it's worth more than the king had in his kingdom. And that's just on a 64-board chessboard. It seems like it's very innocent. Oh, 1 grain of rice, king. 2 grains, 4 grains. And it goes so fast, it's crazy. Zach?
Did he double every square?
Yeah, he said he wanted it doubled every square. Okay? So that's the power of exponential growth. Now, can we break this down just for a second here? You see why we have the 1, right? And we see why we have this. Be careful of this t. You got to make sure you know what time frame it is. Like for the bank, most of the time when you're going to get a loan from the bank, you pay back interest every year. Okay? So if it's yearly, then that's going to be the thing. If you get loans from like a loan shark, you know, like the mafia, it's probably going to be every week or every day or something. It's going to go up very fast. There's the opposite phenomena, which is not exponential growth, but it's going to be exponential decrease. What do you think is going to be different about our formula here? There's
going to be no 1.
No, because we're going to, like, an exponential decrease problem, like an example would be, if you got a car. You buy a new car, you drive it off the lot, and immediately it starts going down in value. But it doesn't, we're not going to get rid of the 1 because then, like at the end of, let's say it goes down in value 10% per year. I don't think that's really true, but I'm just making that up. At the end of 1 year, you're not going to want to have no 1 because then you would just have like 5% or 10% of your car left. That's not what you really want. What's going to be different, Samantha?
You change it to minus.
Exactly. You're going to be minusing a certain percent every whatever the time frame is. Does that make sense?
Yeah.
So let's do the car one. Let's say that you bought a car for $10,000 And it goes down. I should have looked this up, but I'm just going to pretend that it went down 10% per year. So 1 minus 10% is going to be 0.1, right? And let's check it out at the end of 10 years. Tell me what your car is worth now. You at home have a choice of picking which student you want to give the answer. Text in 1 if you want Laura Hartley. Text in 2 if you want Bennett.
3.
Text in 3 if you want Max Buchanan.
Number.
Okay, shh.
I know you're still recording.
Laura Hartley, at the end of 10 years, what's your car worth?
$3,086.78.
That's why cars are not good investments. Okay, you bought it for $10,000 and it just goes down every year. I think there's something I've heard like as soon as you drive it off the lot, it's like, I don't know, 20% less than what you could. So in other words, selling a used car, it's automatically chopped a whole lot of the price off. Okay, so exponential decrease would be just taking away something. Now, one last thing before we leave. Okay? Oftentimes when you see this formula written out, is they will just combine these two. I like breaking them apart because I can see that the 1 gives you back the original amount and then there's a certain percentage. But a lot of times they'll write it like this. Y equals the starting amount, and then they'll just say times 1.4 and then a certain number of years. So you can break that apart in your head. This is the 1 that I told you about that gives you the original back. And then what's the percent of increase per time period, Natalie?
40.
It's going to be 40%. Does that make sense? So they're just going to combine it. Don't let that freak you out. Okay? All right, there's exponential growth. I'll see you tomorrow, you at home, and you in the class. Time to get to work.
Deuces.
Peace out.
Yup.
Dude, they used to